Ion channels are different than the sodium potassium transporter. Ion channels are completely passive, whereas the sodium potassium transporter takes a lot of energy to run this pump. Ion channels are completely passive. So, quick review. We have we've talked about so far two ways to get through the membrane. There's leakage. Two was a sodium potassium pump. And third are going to be these ion channels. What are these? Again, these are ways ions cross the membrane, in or out. Now, ion channels are completely passive. They have two states. Either the channel is closed or it's open. When it is closed, ions like sodium, potassium cannot cross. The channel's closed. When the channel opens, ions can freely cross through the membrane, through the channel. Now, what do you suppose? Let me pause with that question. These channels are specialized. There's a special sodium channel, a special potassium channel, a special chloride channel, and so on. And a sodium channel, guess what? Only lets sodium ions through. A potassium ion ain't gonna make it. Right, for instance. Okay, so these are specialized. So when the gate of the ion channel is closed, nothing's moving. But when the gate opens, what do you suppose determines whether ions come in or go out? What determines? Of course, it's the forces. The forces. If a sodium ion channel opens, which way is sodium going to go? Is it going to go into the cell or out? It's going to rush into the cell. Rush. We say the term rush to separate this from little old leakage, because this is tiny numbers. This is relatively lots of ions. What if there's a potassium channel that opens? Is potassium going to leave the cell or come into the cell? It's going to leave the cell. How do I know that? Because diffusion rules the day. Diffusion wants it out, diffusion's going to get it out. Even though the EP is fighting like the wind, diffusion still wins. These ion channels are critical because the action potential turns out is a synchronized dance of the precisely timed opening and closing of ion channels. Now, these ion channels are voltage gated. What does that mean? Now, gating just means like if you have a gate in your fence, it's closed or it's open. What this is saying is it is voltage that determines whether the gate is closed or whether the gate opens. What voltage am I talking about? I'm talking about that good old voltage measured from inside the cell. Again, it is a synchronized opening and closing of voltage gated sodium and potassium channels. That is the action potential. And in the next video, we're going to spend a good bit of time on this very, very important slide.